So hey everyone, welcome to the Helix Hacks 3 Introduction to Machine Learning. So if you're not familiar with machine learning, we're going to go a little into machine learning, what specifically we'll be talking about, and then we'll be going through an example that you can further look at with some other documentation. So yeah, let's get started. So what is machine learning? There's a few different types, but basically machine learning is where you're given a simple way to explain it is where you're given a set of outputs and inputs, and you have to figure out how to match those two and some kind of model to match those two so that you can predict on a different set of inputs and outputs. So I guess the most basic example, which is most relevant to our case, is if I were to put a blue shoe in front of you, and this is all based on human intelligence, so that's why there's artificial intelligence. So if I were to place like a blue shoe in front of you and tell you that's a blue shoe, your input would be a blue shoe, your output would be the label of a blue shoe. Then if I were to put a red shoe in front of you, then you wouldn't know what to do because you don't know what label that's assigned to. So that's why if I were to put a red shoe in front of you and then say that's a red shoe, then if I were to put another red shoe in front of you, you'd also say that's a red shoe. So that's called training data, and then the data to test it is called testing data. So we'll get more into this now. So basically the network that we'll be working with, or the model, is called a convolutional neural network. I don't expect you to know what that is exactly, so that's why I made this little slideshow presentation about it. So yeah, convolutional neural networks. So first off, what is a convolutional neural network, or a CNN? The most common use for a convolutional neural network, or CNN, is image analysis, because what it does is it basically looks at it uses its baseline data as pixel values. So if you know how an image is, you can see an image like normally, but when you actually look into how it's processed, there's each like values of pixel values. So it's basically like a 2D array of pixel values, or like basically if you want to think of it as like a matrix of pixel values. That's what makes up an image. So the CNN analyzes those, and it's made up of multiple layers, which is another pretty good benefit of it, which we'll see when we start coding it. But it's basically made up of layers that continuously condense down the image until it gets to outputs to predict what the image actually is. It doesn't require much pre-processing as other algorithms. So in many other algorithms, you often need to sort out different parts of the data. You need to change different parts of the data. In CNN, you often don't need as much pre-processing, as you'll see in a bit. So then, based on the neural network that has reception in the human brain, basically the neural network in the human brain is what drives this idea of the CNN, and it's how we ourselves classify images. So back to the blue shoe, red shoe example, the way we can say that something is a blue shoe or a red shoe is the neural network in our brain. So our goal when we're coding things like a CNN is to basically emulate the kind of neural network that we have in our brain onto a computer and allow it to have the same knowledge. Because as many of you guys know, the computer is obviously always going to work. It doesn't have human factors like, sleep, rest, things like that. So we use that to try to make it a lot more automated and the whole process automated. So yeah, someone asked, is self-driving cars using CNN? So yeah, self-driving cars are a great example of CNNs. Basically, if there's a car in front of you or a human in front of you, a car uses its cameras and images generated from those cameras to identify whether it's a car or a human. So yeah, hope that answers your question. But yeah, self-driving cars use CNNs too. Okay. So as I talked about, there are many layers to CNN, and all those layers make up what's called the architecture of a CNN. So the first layer is the input layer. As you can see in the image, the input layer is basically just your normal image. So whether that be the image of the red shoe, the blue shoe, or in this case, we're trying to classify what digit it is of handwriting. So this would be a number 2. So it'd be an image of number 2. Then we go into the convolutional layers. This is like the meat of the convolutional and pooling layers. So this is the meat of the entire network. Basically, what this will do is it'll use a filter called a kernel, and it'll look at a section, and it'll average sections of, so in this case, it's a 5x5 kernel. So it basically looks at 5x5 pixels, and it averages the sections and does calculations to condense down the image and its certain features. And then pooling basically condenses it down further, as you can see here. And then so that always follows a convolutional layer. And the pooling and convolutional layer are repeated multiple times in a network. Then we have the flattened layers. So after you have your, dimensional data, which is basically like, how every image has like a 2D or 3D image. Basically, you have such X dimensions, and you want to make sure that you can analyze it effectively. So the way that you can analyze it effectively is have something called a flattened layer. So basically what the flattened layer does is it takes all of the data that comes out of the final pooling layer, and then it flattens it into one array and in like one vector. So it doesn't like have multiple dimensions to deal with when it's talking about like when it's trying to predict. And then we have the dropout layer, which we'll expand more onto. It's not that important as to now, and you can research it by yourself, but I'll talk about it later too. And then you have the dense layer, which basically takes whatever happened in the flattened layer and it basically predicts from the data in the flattened layer and connects it to outputs, as you can see here. Okay, so yeah, now we can go more in depth in each of these layers. The first layer is the input image, and that's basically, your exact image. So usually it's separated between 3 color channels, the RGB, which is red, green, and blue. If you don't know about that. So then what it does is it tries to reduce the image initially to analyze it. So as I talked about, the image is usually made up of pixels. That's usually what the machine learning algorithm analyzes. So you can see here, it's a picture of a lung. This can not only serve as an example of an input image, but it also serves as something of a basis of an idea. So the reason we're giving this CNN lecture is because in a lot of your projects, what you could do is you could classify things like certain diseases and in whatever way interests you. And I'll send you guys a link to some data sets that you guys could look at if you want more ideas and other things like that. So that's definitely going to be a useful tool to classify, whether it be images of different parts to classify disease or something like that. Then you got the convolutional layer. So this is in Python, it's going to be called conv2d, and we'll see an example of that. But basically what it is it has this kernel, which, let's see if I can get a laser pointer on. Yeah, so it has this kernel right here, which basically looks at, or kernel is basically a filter, and what it does is it moves across the image. And basically, as a result of like moving across the image, it analyzes different features. So as you can see, it moves through across the image with a whatever 3x3 it seems filter. So yeah. And then there's also some padding here, which is basically just the outer edges of an image and things to analyze too. So the goal obviously is to extract important features in the convolutional layer. So whether that be things like edge detection, different like sizes of different parts of the image, things like that. So yeah, the next is the pooling layer. And this pooling layer, okay, so the pooling layer, basically the goal is to decrease the power needed to process the data. So obviously you're analyzing an image. So usually that logically probably mean that you're going to have a lot of, data being used, a lot of processing power being used because, I mean, you're analyzing an image. And usually you run for what's known as like 500 training cycles or epochs, or some crazy amount. So you want to decrease the power per, analysis. So starting off, there's a few different ways that you can pool, and the most common one is called the max pooling layer. It's pretty well represented here. So as you can see, as the image moves across, it creates a little filter right here. So this was the 3 by 3 by 2 so this 332 to 312, this much. So we know that the max value here is a 3, meaning that's what's reflected into this array, as you can see by the animation. However, there's also other pooling methods. This is known as another one is known as the average pooling method, which basically just would take the average of every value in such a box, and then it'd put it into here. So yeah, also feel free to ask me any questions. Yeah, using the Q&A function or the chat function. So then we go into our flatten layer. This is basically pretty important because what it does is it takes results from whatever happened in the final pooling layer and it transforms it into one vector. Basically, this happens at the very end of your neural network, and it makes it easier to analyze because instead of looking at the multiple dimensions that you see here, you're only looking at the straight line of data, which makes it a lot easier to come up with and connect outputs to basically the data that is going on over here. And that's exactly what the dense layer does. So basically you have your flattened vector thing here, and then what it does is it attaches each of these such values to a different output based on different calculations and features that it has, and like preset training data that it has. So if you're identifying a dog or a cat, basically take these values and then it'd be like, oh, that's what's similar to the features of a cat, or oh, that's what's similar to the features of a dog in the 0.1 case. So yeah, that's it for the presentation. So now we can look at a simple demo and talk about it. The workshop isn't too long. I wanted to make sure that you guys had time to work on your projects, so made this quick. And any questions, because I know this may be complex, but yeah, let me know if there's any questions. I'll take a break for any questions. And if you use the Q&A function, it can be anonymous, so don't. So I sent you guys a link to a document about Python, about basic Python resources. This will be useful if you want to do anything in Python, not only in the hackathon, but in the future. And also, if you want to understand this a little bit better, I'll try to explain it in simple terms. But yeah, how can a high school student start into ML? Well, you're already starting into ML by being into this workshop. This is like a pretty good introduction, I think, in machine learning. But yeah, so I'm a high school student. I think the way I started, I guess, and I can speak on my personal experience, obviously, like, there's different ways as to how people learn how to code, and that's totally okay. But how I started into machine learning is, first off, you need to understand, in my opinion, how everything like conceptually works, which is why I gave you guys that slideshow. Also here, wait, speaking of slideshow, let me send a link to the slideshow so you guys can have it for your reference. I'll send it after it's on. But yeah, so how can a high school student get started into ML? Basically, I think the first step is understanding things conceptually, and like I think that definitely like helps out a lot. But also like I think projects are the best way to do so. A lot of people like their first instinct is to go into like a textbook and maybe just like do like X amount of pages a day or something and try to learn coding and machine learning overall. I don't think that works. I think the best thing that works is projects because they allow you to apply your knowledge and then you'll also learn a lot more. And it's also a lot more interesting because honestly, like for me, reading a textbook was always like pretty boring. So definitely working on a lot of different cool projects like like maybe if I think you asked a question about self-driving cars, and if that's what interests you, go ahead and like find some simple data set about car images or like traffic data, and then start coding away an algorithm that detects whatever you want it to detect, and then through that you'll be forced to understand different concepts and different like coding algorithms, which is like pretty useful. And yeah, so I think projects is definitely key. There are a few courses I can quick plug ours, which is I think a very good course because it takes you through a lot of basic machine learning concepts, and it is bio focused, but it also does have a lot of machine learning concepts. So yeah, feel free to check that out. And I sent a link to that in chat. Okay, let me know if you have any other questions about that. I'm more than happy to talk about that. So yeah, I guess we can get started into the coding. So the first step you want to do is go to this link in the chat. Oh, I've been sending links to only panelists. Here, let me forward you guys. Okay, so here are the Python basic resources that I was talking about before. And then here is the link to the courses that I was talking about before for machine learning and stuff like that. But yeah, in terms of the workshop, getting back here, the first thing we're going to code a simple CNN to classify just a bunch of different objects. So the first thing you want to do is go to, open up the chat, send you guys a link. Go here. So this is called Google Colab, and it's a software obviously developed by Colab. Basically, it's an extension of Google Drive. So it's really convenient because, as many of you know, like Google Drive is like pretty convenient in terms of sharing things like code or sharing things like documents, sheets, things like that. But also like it's pretty simple, and you can just start like coding away. So it basically just allows you to execute a bunch of machine learning stuff in your browser already. So the first thing you want to do when you get to this Colab screen is click File, New Notebook, and then start a new notebook. Let me know when you're done with that. Type in chat when you're done with creating a new notebook. Is it important to have a good understanding of terminologies before starting projects? I think you should have a basic level of understanding of not terminologies, but rather concepts before starting some projects, but also realize that you'll learn a lot more about different concepts in projects. So you have to find the middle ground and making sure that you don't give up and about your projects, but also making sure that you can follow along. Yeah. Okay. Is everyone at the place that I said? Colab Research Google. Is everyone there? And then you create a new notebook. Here, I'll push a poll. Okay, it seems that everyone's there, so let's go. Okay, cool. So now that you have a new collab, the first thing you're gonna want to do is import TensorFlow, which is TensorFlow basically is the like holy grail framework of machine learning. TensorFlow is what you're going to be using to implement a lot of your machine learning concepts. So definitely get familiar with that. So import TensorFlow as TF. For those of you who don't know Python, as TF will basically just make it easier for you to type, and you can just type TF dot whatever when you're using TensorFlow. So then the next thing you want to do is from TensorFlow.keras, you want to import three things: datasets. So Keras, so really quickly, Keras was an independent framework that did its own machine learning stuff. Then TensorFlow acquired it, and now they work one in hand, and they're very Keras is a very good place to work on neural networks. So yeah, so from TensorFlow.keras, you got to import datasets, layers, models, which are the three things we'll be using. So the datasets, we'll be using a dataset called the CIFAR10, which is basically just like a bunch of images, and you'll get a taste of what those images are. Then you got your layers, which we talked about in the slides. Basically, the layers are, your convolutional layer, your pooling layer, your dense layer, your flattened layer, things like that. Then you have your models, which is basically, your CNN model, and it'll create the basis. We'll talk more about that as we go down. Then you want to import matplotlib.pyplot as PLT. Basically, this will allow you to plot some data, and we're going to show you as to why that's useful in a bit. So whenever you're ready with that, go ahead and type in chat, like yes or something when you're ready. And then I'll move on. Or share screen. Okay, it seems like everyone's done with the first step. Okay, so then the next thing we're going to want to do is now we want to look at the data. So basically the data is called CIFR FAR10. Also, remember to run everything as you're going so you know we don't have to go back and have any problems. But yeah, it'll basically take a second and then it'll run it. Okay, cool. So now we have that run. And then the next thing you want to do is, as we talked about before with the blue shoe, red shoe example, there's something called training data, which tells you if I were to put a blue shoe in front of you and say that's a blue shoe, that's me giving you training data. And if I were to put a blue shoe in front of you and not tell you what it is, then you'd have to say blue shoe. Or if I were to put the testing images and the test data is basically like if I were to put a blue shoe in front of you and ask if that's a blue shoe. But yeah. So basically you have your training images, training labels, and then your test images, test labels. So basically this will automatically split your data for you, this line right here, into images, labels, test images, test labels. So, and then you do datasets.cfir10, which is basically a built-in function of Keras that loads this specific data set, which is a very popular data set. All right. And then the next thing you want to do is in your train images and test images, you want to make sure that the pixel values are in the RGB scale, which is basically values between 0 and 255 for each of the values of RGB. So what you do is you do this train images over 255 and test images over 255. So you can normalize the data and make sure it's the same values. Okay. Okay, so someone said they need help. Whoever, okay, yeah. So take your time. Sorry, I think I clicked off the tab. Okay, sounds good. So whoever said they need help, please use the chat, and if you click all panelists, if you're not comfortable with asking in front of everyone, I'm the only one that can see it. So please feel free to use that function. I want to make sure you guys get this. Oh yeah, you're good. And if there's any questions about like misunderstanding as to what the code does, let me know. Okay, is anyone not good to move on? Those are the ones I'll just move. Okay, sounds good. Let's move on then. So, this, okay, so make sure you run the data, or this, and then it'll say downloading data. So while that's downloading, this, since it's not like that, necessary to copy. So feel free to copy and paste this code into your Colab. This won't be that necessary for you to understand how machine learning works. It's kind of complex, but feel free to copy this in your Colab and then just let me know. So yeah, basically what you should get when you run this is a bunch of blurry kind of images of different things. So for instance, and with their labels, right? So you have, because this is the training data, as you can see by train images, train labels. So yeah, as you can see, it classifies it as a truck, a deer, which looks like that, an automobile, frog, blah, 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 blah. You see like 25 of them. This is only like a small subsection of, our data, but it gives you a good sense as to how our data looks. So yeah, run that, and then since you guys should just copy and paste it, it should be fine. Okay, so then we can move on to the meat of this entire project, which is going to be your machine learning algorithm. So starting off, you want to use something called the models.sequential. Basically, you have model equals models.sequential. This right here will start the basis of this whole layered program. So remember, the convolutional neural network is a layered network. So this right here is basically going to create a base for you to put your layers in. So think of it like a bread basket, and you're just putting in your, slices of bread, which are your layers. So this is your bread basket. Then we go into each layer. So the way you're going to add your layer is just model.add, pretty simple. And then you start coding your layer. So what you're going to want to do, I'll walk through each part of this. So layers.const2d. So the first part is how many filters you have. So remember, we looked at if we go back to the slide, we looked at this is Python. But yeah, so this is Python. That's the main language of machine learning. So yeah, as you can see in the convolutional network, we have these little filters which are going over the image. So this right here determines as to how many of such filters we want. So in this case, we said 32. This is going to determine the size of such filters. So 5%. Then this determines basically this size. So, yeah, this determines this size basically, right here. This size. The size of the 3x3, 3x3. So that determines this size. Then you have an activation function. You don't really need to know much about this, but ReLU is the most common one. And it basically just there's a lot of math behind it, so it won't go too in depth in that. The input shape, basically it's just the shape of your image. So in this case, we had a 32 pixel image by a 32 pixel image, just, width and height. So in this case, something like this. If you were to take this would be 32 pixels. This would be 32 pixels. Then the 3 at the end is talking about RGB. So a 3 is just the number of color channels you have. And that's basically, the color channels in our case, which the 3 color channels would be red, green, and blue, the RGB color channels. Then we add another layer, which is the max pooling layer, which we already talked about in this slide. This slide here. You can see the max pooling happening here. So basically we want to add a layer to max pool. So the way max pooling works, as you can see, is in this case, it looks at 3 by 3, but in our case, we're going to want to look at a 2 by 2 section of the pixels, which are here. So yeah, that's our max pooling layer. And that's just layers.max pooling 2D. Then you want to add another convolutional layer. So if you remember from this part, this image, we have multiple convolutional and pooling layers. Here it's 2, but obviously there's more. So you'll add 2 here as well. Yeah, you should write the model.add code as well. I'm just explaining it, so you should be typing while I'm talking. But yeah, basically conv2d and the same setup. So 64 is the number of filters. This is the size of each filter. This is the activation function. Pretty simple. Then you add another max pooling layer, and then you repeat. Basically the same thing. So yeah, everyone got that? So the next few layers we're going to add are going to be the flatten and the dense layers. So remember, this is going to flatten the data into one vector. So you don't really need to add any parameters in this case, because all it's going to do is flatten it into one vector. This dense layer is going to condense whatever data you have down into 64, and then using an activation function of ReLU, and then that is going to dense it down into 10, which is the number of outputs. So if we go back up here, it says the CIFR data set contains 60,000 color images in 10 classes. So that's how many classes we're gonna be using. So in this case, our 10 classes were these, and we're gonna want to classify images in those 10 classes. So that is why the data is 10, because we're gonna have an output of 1 in 10. Then the model.summary should be running these. But yeah, so now that we're finished creating our model and adding every layer into it, we look to the model.summary. Now this is going to give you a rundown as to what you just created. So as you can see, and it's going to go in order, so and show you exactly what's happening. So as you can see, we start with the 30 by 30 by 32 after the conv2d. Then we're going to condense that into the max pooling 2D, which is a 2 by 2, so it halves basically. So that's 15 by 15 by 32. Then we're going to go back into a convolutional layer, which also condenses it and makes it 13 by 13 by 64. That's going to basically have that and then go 6 by 6 by 64. Then going to condense it. Yeah, I'll send the link of the code after. Yeah, I'm giving you guys time to write down that. So, but yeah, so there we go. And then after that, you got your 1024. So now you can see it goes from 3 dimensions to 1 dimension after the flat layer. And then it denses down into 64, and then it denses down into 10, making your output. Okay, cool. So here, I'm gonna send out. Oh, someone raised their hand. Oh, they left. Okay. Okay, I just launched a poll just to see where you guys are at. Yeah, no. Okay. I'll give you guys a few minutes to copy this down. We're almost done, so hang in there. As soon as you guys are done, if you guys could just change your answer, or at least text me yes in the chat, that'd be great. So I can move on because we're running out. Yeah, so the reason you don't need semicolons at the end of this code is because this is Python, and in Python you just don't need semicolons. That's a Java C kind of thing. Java doesn't need semicolons. I'd recommend looking at the Python basics resources, which I sent above, if you have any Python level questions, but I can answer anything if you want. I'll resend that there. Okay. I'm gonna send a link to this. Just 1 sec. And then you guys can just look through it and code at your own pace. There you are. So yeah. Basically the next thing is compiling and training the model. So now that you have everything, done and you've created the model, now you actually want some results. So this is where the training and the evaluation of the model come in. So the first step you want to do is compile the model. Basically, you use the optimizer, which you don't really need to worry about for now, but basically it's a function called Atom, which basically just like optimizes your code in simple terms. And the loss function, things like that, accuracy. Then you want your loss, which is, you can just copy and paste this, but basically this is this is a way that you can record your losses. And basically a loss is like how off you were from the actual result. Metrics. So the main metric you're going to be evaluating is accuracy, obviously, because you want to see how accurate your model was in classifying images. And then the history is going to be used to plot it. But basically what history does is it basically like sets up your model. So it does model.fit, which sets your training images, your labels. So basically that'll input your training data, and then it does that 10 times to make sure that because the more times you input training data and the more times you train it, the more accurate your model should be. And then it uses validation data, which basically validation data is like validating how well your model works. So it'll give you these test images and see if you passed it using the test labels as comparisons. So you want to run that code. Then you'll see it pops up with the epoch 1 out of 10. Then you'll see it does that 10 times. Basically, we'll just run this code. And then you guys can just copy this one, the PLT stuff, because this is basically just gonna, I'll explain it to you when the graph is created. This is when it is. It's just setting up the model so it'll start running faster. Just give it a couple seconds. Oh, could you guys not see my? I sent the code, so following along with that. So now you have your 10 epochs running. And then, yeah, for the evaluating the model, you can just copy that code because you guys don't really need to know like how to, like type this all out because usually it'll be manual. So yeah, now you got 10 epochs. And then, so one thing right off the bat you can notice, and we'll see this more visually in the next step, the loss in number is going down. So that means which is also why your accuracy as it trains more is going up. So you have about a 78% accuracy at the end. This is the validation loss, which is basically an evaluation of the validation data, which is your test images and your test labels. So now this one stops running, this one will start running, and then this will create a graph that visually shows you as to how your data performed and how your model performed. Then you'll see how it works. Sorry, it's a little slow today. So yeah, as you can see here, you have your graph. This is your accuracy. It's basically plotting by epoch, which is, your 10 epochs, your 10 training cycles, and how that affects your accuracy. So as you can see, accuracy is definitely increasing, and so is your validation accuracy. So overall, model's probably working. Then you have this model.evaluate, which basically sees how your model works in a generic sense and not only on the training data, and uses your test images to verify that. This creates a test accuracy of about 70%, a little over 72%-ish. So yeah, that's basically it. So I'll take any questions now. And if you don't have any questions, feel free to head out. But yeah, thank you for listening. Oh, seems like I got a question. Yeah, no problem. Feel free to head out if you don't have any questions for me. Oh, seems like that's true. Okay. Thank you guys so much.